Okay, welcome grade 8s. We're going to be looking today at 8.2. In 8.1 we learned to draw the 2D views of different shapes. And in 8.2 we're going to be looking at rotating these objects and then drawing the views of the shapes again. So basically just seeing how the different shapes have changed after a certain rotation. Okay, so there's two main types of rotations. We've got horizontal rotations and we've got vertical rotations. And I just want to clarify a couple things before we get into looking at some examples. This is very, very important to understand the difference between these two. So first of all, a horizontal translation or rotation, sorry. I don't always think of things in terms of food, but in this case I think it's kind of a nice one to use. Horizontally, when we rotate something horizontally, you'll see a couple of terms used, the axis of rotation and then just that it's rotating horizontally. So when something rotates horizontally, I think of it as a microwave, right? In a microwave, your food might turn around, right? And it's rotating around. It's actually rotating horizontally. The axis of rotation, I actually just using this to help show, if I take a cube and I start rotating it, the actual axis, I can imagine that as the thing that it's rotating around is actually vertical. And this is where there's some confusion because we see that line, that imaginary line, we think, oh, that must be vertical. But the line will be vertical and then the shape will rotate around that line. Okay, but it's actually a horizontal. We're rotating horizontally. Okay, whereas if you were making a nice shish kebab and you put some meat on a stick, this is more common. You put that over top of the fire. I'm getting hungry just talking about it. But the meat is going to be rotating along a horizontal axis of rotation. That's what we call this imaginary line, but in some cases you'd actually have a physical stick, right? So that axis is horizontal, but my meat, or in this case my block, will rotate vertically. It's going to rotate around like this. So very important to keep those two terms straight. If you're rotating horizontally, your axis is vertical, and when you're rotating vertically, your axis is horizontal. Okay, so hopefully that makes some sense. Now, we would normally work a little bit with this before getting into some of the work. So you can kind of just follow along with me on here. I just made a random shape that has six cubes, made up of 6 cubes. And I'm just gonna kind of show you the difference between some of these turns. We're gonna look mostly at these, okay? Rotating 90 degrees one way or the other, or 270 degrees. Really the main rotations we're gonna deal with are these ones, okay? So in other words, a 90 degree, if you remember back to some work you might have done with this would be a quarter a turn, a half turn, and a 3/4 turn. We're not going to make you rotate a shape anything different than that. Okay, so here's my shape, and we'll just touch on clockwise versus counterclockwise, horizontally first of all. So if this is my shape and I say this is my front, and this is my left side, this is my right side, this is my top view of a shape, and I have this shape. Now if I'm rotating it horizontally, I'm going to try to remember, kind of like with a skewer thing, I could imagine, I don't know if I can kind of go through this, but I could imagine if I'm going to rotate it horizontally, then I'm imagining a vertical axis, meaning it's going to spin around a vertical shape. Okay, so I can kind of imagine it like that. Now, the trick for me, I always look at it from the top, right? When you're doing a horizontal translation, you're going to actually take your shape and you're going to look at it as if you're peering at it from the top. And that's where your clockwise or counterclockwise is going to go, because otherwise it doesn't really make sense. Well, what's counterclockwise if I'm looking at the shape like this? If I peer at it from the top, now I can look, okay, what's going to be clockwise this way is going to be clockwise. So I peer at it from the top, 90 degrees clockwise. I'm just going to shift the shape a quarter turn clockwise with the clock. Now, this is not my front view. I have to remember I'm looking at it from the top, so this would become my front view now. Okay, and we'll get into it in some of the examples, actually drawing the new front, side, and top views, but we'll just get the hang of it hopefully with an example here. Okay, so if I go back to my original shape, this I deemed the front of my shape. So if I do a horizontal 90 degrees counterclockwise, hopefully you can see that if I look at it from the top view, here's my top, 90 degrees counterclockwise, I'm going to go the other way, right? So I'm going against the clock, 1/4 turn. Again, that's my top view, so my front view would look like this. Okay, so there we go. Going back to my original shape, and we'll touch on 270 clockwise. I can think, okay, clockwise, that's 3/4 of a turn, 270 degrees. So if I'm looking at it from the top, 1, 2, 3, that's 3/4 of a turn. There's my front shape. You might notice a relationship between this shape and the one we just did. Well, I know some of you are screaming into your computers that you know that the reason that there's something similar here is because these two are actually exactly the same, and that relationship will always be true. If you're rotating something 90 degrees clockwise, it's always going to be the same as the opposite, 270 degrees the other way, okay, and vice versa. Okay, so a 1/4 turn this way is going to result in the same thing, 3/4 the other way. Okay, so those are for horizontal. You're not going to use it for vertical translations if you're, rotations. If you're pushing it, it's either going to say rotate it vertically away from you or towards you. And you can imagine the thing's actually going to fall towards you or fall away from you from the top of the shape. Okay, so we'll get more into that in some of the examples there, but that's a few things you're going to need to know for your rotations. And hopefully this becomes more clear when we actually get into a couple examples here. So we'll take this one right here. I've got, oh, would you look at that? I've got the shape ready to go. It looks exactly the same. Here's my front shape. So going back to 8.1, we know that if this is my shape, I'm going to kind of try and zoom in for you. There's my front. It's all on the same plane. That's why there's no lines connecting. It's showing that those three squares are all the same. So I go to the left side, these two are the same, this one's not. That's why this is separate from this. And if I go to my right side, these two are on the same plane, this one's not. That's why we have here. Okay, and if I look at it from the top view, that's where this one matches this one. Okay, so now we have this shape to start with. It tells me what the front view is. It's giving me an axis of rotation. We should be able to do something like this. Suppose the object is rotated horizontally 180 degrees. Notice they don't say 180 degrees clockwise or counterclockwise, because 180 is 180. It doesn't really matter which way you go. You could go left or you could go right, but you're going to get the same shape. Okay, so we just have to rotate this. So again, I'll try and give you something to see here. If I'm looking at my shape from the front, I'm taking it from the top view. I'm peering at it from the top, and now I'm going to rotate it 180 degrees. So there's a 1/4 turn, 1/2 turn, or in other words, 180. And notice that now becomes my front view. So you can see, I'm not going to actually go through this example, it's in the book for you to look at, but you can see that that is now my new front after I've rotated it. My left side, right? My left side looks like this. You can see that it matches. Go back to the original. Right side, right? There's these two are together. This one's out, okay? And then from the top, right here. There we go. Okay, so you can see there's my, looking at my horizontal 180 degree rotation. Okay, I think there's one more here looking at us rotating it vertically, so I'll show you the difference there. So suppose the object is rotated vertically 180 degrees about the horizontal axis. So then I'm taking my shape, I'm looking at it from the front, and I'm thinking, okay, if it's rotating 180 degrees, it doesn't have to say away from me or toward me, because it's going to be the same thing. Either way, you're doing two rotations, whether it's this way or whether it's this way. Okay, you're going to get the same looking shape. Okay, so I'll just hopefully zoom in for you there. So 1/4 turn and then a 1/2 turn, or 180 degrees. Okay, about the front of it. Okay, oh, they actually, okay, that is the right shape. Okay, so we just took that shape just like that. Okay, and you can see that that is indeed the front. It's just this part is separate from this. Go to the left side, This part is separate from that. That's where we get this from. Go back to my front of it again. If I look from the right side, this works. And if I look from the top, you can see it's all on one. Okay, so hopefully you can get the hang of it. We'll actually go through a few examples here where you've actually got to do it.